Okay, so we're talking about a little quick review on some geometric series. Geometric series, of course. Looks like, well, we'll start it at 0 power first. That's just 1 plus a squared plus and so on, right? And the sum we know is 1 over 1 minus a if the absolute value of a is less than 1. Good. And then the only difference if you don't start at 0, but if you just start at the kth power, right, so that would be a to the k plus a to the k plus 1 plus and so on. That sum is going to start with a to the k on top minus divided by 1 minus a, and that's again the restriction is the same, converges absolutely when the absolute value of a is less than 1. Good. All right. Those are pretty straightforward to prove, and it's actually kind of a nice proof. I think we won't prove it right now, but we might take a look at it later. We might just do a quick example of how this works. Right, if I take, say, I equals 1 to infinity of 2/3 to the I power, right? That's going to be my first term was on top, so that's going to be 2/3 to the 1 power divided by 1 minus 2/3. And so that's going to be 2/3 divided by 1/3. And so that's 2/3 times 3 over 1. And so that's equal to 2. Okay. Now, we want to consider base 3 expansions of fractional numbers. Consider base 3 expansions for numbers. Okay, and so, if you're given a number 0.s1, s2, s3, dot, 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 base 3, that's equal to s1 times 3 to the minus 1 power plus s2 times 3 to the minus 2 power. This is base 10, right? Plus s3 times 3 to the minus 3 power, and so on. Okay, so for this to converge, right, S1, S2, and S3, or I'm sorry, SI in general, SI generally is in the set 0, 1, or 2, right? Because then this sum, right, would actually be, in base 10, it's the sum I equals 1 to infinity of SI divided by 3 to the I power, right? And so if SI is either 0, 1, or 2, right, then we know that this series converges since SI divided by 3 to the I is bounded above, right, by 2/3 or 2 over 3 to the I. Good. And so my sum then is going to be bounded above by the sum of 2 over 3 to the I. Good. So this sum is going to converge. Okay, so that's what it means to have a number in base 3 like a fraction, is that you can convert that. That is equivalent to this. This number then is in base 10. Right? Good. All right. Now, the question is, how do you get a number from base 10 to base 3 or vice versa? So let's start one out. Let's see if we can convert 0.1 base 10 to base 3. Okay. So we're going to start off kind of longhand, and then we'll find a little bit of a shortcut. But the idea here is that we want 0.1 to be equal to I'll call it S, maybe S1, right, times 3 to the minus 1. This is times there. Plus S2 times 3 to the minus 2, plus S3 times 3 to the minus 3. I'll do a couple more, S4 times 3 to the minus 4, and so on. Okay? Now, what happens if I multiply both sides by 3? So I'll just make a note, times 3, then that becomes 0.3 is equal to, now I multiplied by 3, so this just becomes S sub 1 plus S sub 2 times 3 to the minus 1 plus S sub 3 times 3 to the minus 2 plus S sub 4 times 3 to the minus 3, and so on. And so remember, S1 is an integer, and so the integer part of this side of the equation is 0. The integer part of this equation is S1. Therefore, we have found S1 to be equal to 0. Okay? And so now we subtract both sides, S1 from both sides, and we continue. So now I'm going to multiply by 3 again, and so I get 0.9 is equal to S sub 2 plus S sub 3 times 3 to the minus 1 plus S sub 4 times 3 to the minus 2 plus S sub 5 times 3 to the minus 3, and so on. Okay? And now once again, the integer part on this side is 0, and the integer part on this side is S sub 2, so therefore S sub 2 must be equal to 0. Okay? And then we multiply by 3. And so when I multiply by 3, I get 2.7. Okay, so the 2.7 is our S sub 2 plus S sub 3, and so on, right? And so therefore, what can we conclude? S sub 2 must be equal to 2. Sorry, S sub... whoop. What happened there? Did I forgot? I forgot to subtract S2 off of that. Sorry about that. This expression is not correct. When I multiply this expression by 3, I take out the S sub 2, right? So that becomes S sub 3 plus 3 S sub 4. We're going to get a shortcut for this. Times 3 to the minus 1 plus S sub 5 times 3 to the minus 2 plus... Okay, there we go. And now S sub 3 is equal to 2. Subtract 2 from both sides, and you get 0.7 is equal to S sub 4 times 3 to the minus 1 plus S sub 5 times 3 to the minus 2, and so on. Right? And so I multiply that by 3, and I get 2.1 is equal to S sub 4 plus S sub 5 times 3 to the minus 1 plus S sub 6 times 3 to the minus 2 plus, and so on. Okay, and now S sub 4 is equal to 2. Subtract 2 from both sides, and you get 0.1 is equal to S sub 5 times 3 to the minus 1 plus S sub 6 times 3 to the minus 2 plus so on. Okay, now notice that we're back to the beginning where we had 0.1 is equal to this expression, right? And so then we had S sub 1 is equal to 0, then we had 0, then 2, and then what was the next one? 2. And so we've actually finished here. 0.1 base 10 is equal to 0.00220022, and so on. And this is base 3. Very good. All right. Now, what was that shortcut we were talking about? The shortcut is, if you start off with your 0.1, just multiply that by 3, and you get 0.3. Now notice that we're going to pay attention here to this leading integer here. Now I take 0.3, and I multiply by 3, and I get 0.9. So again, pay attention to the 0. Now take your 0.9 and add it over here, or put it over here, 0.9 times 3, and you get 2.7. And now we're paying attention to the 2. Now I don't want to bring over 2.7, I just want to carry over the fractional part. So I carry over the fractional part, 0.7 times 3, and I get 2.1. And again, I'm paying attention to the 2. Carry over the fractional part, and you can see that we're starting from the beginning again. So that's 0.3, 0.3 times 3 is 0.9, and so on. And so what you're reading then is you're just reading the integer parts off of this table. And so what we've concluded then is that 0.1 base 10, whoops, I'm getting a message from Windows. Thank you, Windows. 0.1 base 10 is 0.00220022, and so on. Base 3. Good. And so that's the shortcut. So what did we do then? You just keep multiplying your number by 3 and keeping track of the number over here. And then after you've done that, remember to bring over just the fractional part, right? So we're just bringing over the fractional part into the left-hand side. So I take the fractional part and I bring that over. Fractional part, bring that over. Fractional part, bring that over. Good. And then again, at the end, you're just reading these integer parts of the numbers, and that gives you your base 3 expansion. And this is really what we did up here was actually the proof of why this all works. Okay, so that's kind of fun. So just for practice, we should do one more. And so for practice, show that 0.25 base 10 is equal to 0.0202 base 10. Okay, so you should pause the video and I'll write down my solution and you can write down your solution. Did you pause the video? All right, so let's go ahead and do 0.25. So we'll take 0.25 multiply by 3, you get 0.75. 0.75 times 3, and what do we get? 2.25. Okay, now just take the fractional part, 0.25 times 3, and we're back to where we started again. Right, 0.75 times 3 is 2.25. Okay, so we're going to go back and forth and back and forth. And so therefore we see here that 0.25 base 10 is equal to 0.020202 base 3. Good. All right. So that is our base 10 to base 3 fractional conversion. Good.